سلام و عرض ادب خدمت استاد عزیز و دوستان ارجمند. موضوع سمینارم Evaluation of Reinforced Concrete Structures in Afghanistan based on valid international regulations. I would like to present my seminar in English. The aim of this study is to evaluate the safety of existing and under construction buildings in Afghanistan. At present, most structures in Afghanistan are not designed or constructed primarily to withstand the seismic forces. Limited research have been conducted on the seismic assessment, hazard assessment. There is no currently seismic design code in Afghanistan. The most common type of building in Afghanistan are reinforced concrete RCC buildings. Most of those buildings have been built in the last 20 years and are designed to withstand gravitational loads. This study is based on a survey conducted by the U.S. Agency for International Development (USAID) and USGS United States Geological Survey in Afghanistan in recent years, which identified only the seismicity of 4 major cities in Afghanistan, as you can see in this table. Major cities like Kabul, Mazar-e-Sharif, Herat, and Kandahar. Here is the seismic data for these provinces. This study investigates the seismic damage of 3 most common mid-level RCC building, which is very common and include about 60% of mid-level RCC building in Afghanistan. The selected building for this study is as follows. 1. 12-story RCC building with base plan 46 into 21 meter with shear wall and elevator under construction in Kabul city. 2. 12-story existing RCC building with base plan 40 into 21.5 meter with shear wall as well as elevator in Kabul. 3. A G+7-story existing RCC building with base plan 40 into 9 meter without considering the effect of seismic loading. Because the seismic data for this building is not clear, as I explained it earlier, the seismic data is just for 4 major cities. Here, 4 major cities: Kabul, Mazar-Sharif, Herat, Kandahar. This building is located, the last building is located in the Bamiyan province. We don't have any seismic data for Bamiyan. As 40% of existing and under construction buildings in Afghanistan are not considering the effects of seismic loading or just loading assumption in case of structure design. In this study, I have included the building which considering the seismic loading as well as without seismic loading and design. 3 levels of performance were considered in this study, which include immediate occupancy, life safety, and prevention collapse, gravitational pressure using force control method, and lateral pressure with displacement control using SAP 2000 version 20.2 software pushover analysis. Here is the G+7 existing building in Bamiyan. Main research question. Do the newly constructed mid-level reinforced concrete structures in Afghanistan meet the requirements of existing regulations, taking into account the design earthquake? In general, seismic forces have a dynamic nature, but design code allows in this research to use equivalent static analysis method using ASCE 716 code. According to ASCE 716 and IBC 2012, building should be designed with 2 levels of earthquakes. The effects of an earthquake that a building is designed to withstand, which is an earthquake that has a 10% probability of occurrence during the 50 years useful life of the building, the maximum earthquake that can be expected at the construction site, and it refers to an earthquake whose probability of occurrence during the 15 years of useful life of the building is 2%. The IBC design code is obtained using new maps prepared by United States Geological Survey USGS. In 2020, Parvin Ogu with his colleagues conducted a case study on existing 4-story and 6-story structures, and those observations can be clearly considered in this case. Plastic hinge formation during nonlinear static analysis performed on existing G+3 structure, it can be deducted that some structural components were inadequate. These observations are clearly expressed from the structure of G+5 analyzed prior to retrofitting, as well as from the DCR calculations performed for the earthquake load case. In the seismic analysis performed on G+5 building, unsuitable structural components such as components in the collapsed state were present only in G+3 configurations. Those components are reinforced with steel bonding technique to increase the flexural and shear strength of the beam and to increase the axial strength and torque bending capacity of the columns. Khalid El-Hadi and colleagues evaluated the seismic performance of 6-story reinforced concrete building in city of Abha. Using pushover analysis, the results have been compared in the term of base shear, displacement, and sample of plastic hinge formation. Many results can be drawn from this study. The main conclusion as follows. Pushover analysis can identify weak element by predicting the failure mechanism and account for redistribution of force during progressive yielding. It may help engineers take action for rehabilitation work. 2. The results show that the design by ESEE and IBC 2012 are found adequate. 3. The buildings that were designed according to ESEE and IBC 2012 are satisfactory. The performance point location is at IO, means immediate occupancy level. It means that the design satisfy the pushover analysis according to ATC 40. Assumptions. Evaluation of 12-story building under construction which has 2 underground floors and 10 upper floors. 2. Evaluation of existing 12-story building which has 2 underground floors and 10 upper floors. Evaluation of existing 8-story building which has 1 basement and 7 upper floors. For 12-story buildings in the area with soil type 2 and relatively high seismicity are considered. The 8-story building in the soil type 2 is evaluated without considering the effect of the earthquake. In 12-story buildings, nonlinear analysis performed in the 2 dimensions. Plastic hinges are used to model the nonlinear behavior of the structure. Aim of research. Seismic evaluation of building according to the valid international regulations. Assessing the level of safety performance at the risk level 1. Exploration on the basis with probability of exceeding 10% in 50 years. Innovation. One of the important goals of designing and implementing buildings is to maintain the safety of residents at a certain level of risk. In Afghanistan, there are no building design and load regulations. Usually, the design of building in this country is based on loading assumptions. Few seismic studies in the country show that some of the country's most popular cities, such as Kabul, have relatively high seismicity. Therefore, it is necessary to consider the seismic design criteria in the design of building in these cities. In this study, the seismic performance of several mid-level reinforced concrete structures that have been built in different cities, including Kabul, is evaluated. A review of the technical literature on the assessment of seismic behavior of existing buildings shows that no significant study have been conducted in this field in Afghanistan. Therefore, one of the innovative aspects of this research is to determine the safety margin of mid-range reinforced concrete building in Afghanistan due to the earthquake. Type of research method. This study is a numerical type research, modeling, analyzing, and designing the building in 3D using ETABS 18. For nonlinear analysis using SAP 2000 version 20.2, analyze and design will be according to valid international regulations. Data regarding to this study from valid topics and websites. SAP 2000 is a structural analyze and design software produced by Computer and Structure Incorporated CSI, a structural and earthquake engineering company. SAP 2000 is a general purpose finite element program which performs the static or dynamic, linear or nonlinear analysis of structure system. Data collection. The seismic data from USGS website and other relative data from valid websites. Here is the references. Thank you.